In the name of God and hi to all the students, I hope to be fine and have good time in these days. In the previous sessions, we started the machine learning definition, and we said that what is the machine learning, and we tried to set the fundamental things in this topic, in this issue. We first set the different definition of this, and as you remember, the machine learning is the programming computers for learning from data. And after that, we compare the traditional programming techniques with machine learning system, and in this way we considered one example. As if you remember, we considered if we want to distinguish spam emails, and by this example we compared these two methods, traditional techniques and machine learning techniques. And using this example, we tried to say the advantages and disadvantages of machine learning system. Then step by step we studied these things, and finally, if we consider this slide and we attention to this diagram, we said that if we have the big data, and if we want to use machine learning for this big data, it is clear that machine learning is better than traditional, because in traditional we have to use some algorithms to extract the features of the data. But in the machine learning by itself study the data and extract the features, extract the characteristics, and then after that, using a different structure, using different methods, the machine learning tries to understand and learn from this data to, for example, classifying data. For example, if we have many emails, in the traditional methods, we have to find what is the words for spam emails. But in these methods, in these new methods, machine learning by itself and studying the data itself understand what is the spam emails. So it is so more smarter than compared with the traditional methods. Another advantages, as I say in my talking, this is the big data. Another thing, it is automatic. Maybe its running time is too high in some structure, in some algorithm of machine learning, but the advantages is more than disadvantages. And besides all of these, for example, if we have new data, then the machine learning have these options to update itself according to this new data. In addition, the applicant, the human, the users, the person who wanted to study this problem can learn from the output of this algorithm, of this machine learning algorithm. For example, the human can understand what is the spam emails from the output of the machine learning algorithm. And this slide summarizes these things. After that, we started to study the types of machine learning systems. We studied supervised, unsupervised, semi-supervised. As I remember, we studied these three system learning. We said that in supervised, each data have a label, and in the unsupervised, we don't have this label, and the system see the data, and according to the parameter, according to the initial parameters, it can understand what is the classification of this set, of this data set. And it is clear that semi-supervised is the middle of supervised and unsupervised. Some data have label, and system according to this labeled data can use some similarity parameters or any other methods, and classify other data. And if we have a new data according to this method, for example to this similarity, system can understand that it is this cross data is related to triangle or to square data. And another learning system is reinforcement. Reinforcement is like a game. You imagine a game designer. That person, when he or she, game designer, wants to design and wants to introduce a game to a player, said that okay, this game is this, the goal and the rewards in this game are these things, and the penalties are these things. But the designer, the game designer, never say the role, the way how to achieve these rewards, how to stop the penalties. Only say the goals and the rewards and penalties. Okay? And the player, after playing that game, understand that how to achieve the rewards, how stop to not to receive penalties. Okay? And this is the policy of that game. Reinforcement is like this, and the learning system in this method, in this type, called agent. And agent agent knows the reward and penalties, but agent doesn't know how to achieve them. And then if we have data, if we have an environment, of course in machine learning we have data, maybe that data is signal or image or any other things in any fields. The agent see all the data, and then finally by error, by getting and achieving some errors, the agent learns how to classify, for example, objects. Okay, this is reinforcement learning. Of course, if we want to know the exact things, for example, if we want to know the exact reinforcements, the exact I don't know, semi-supervised, maybe each of them has many knowledge, has many information, has many methods. We only, in these PowerPoints, we only want to familiar with these words. What is the semi-supervised? What is the reinforcement? As you see, reinforcement is like a game, okay? But the disadvantages is it is very time consuming. And if we want to use this learning system, then we have to more than about this. Okay, another topics in this field is batch and online learning. We can understand these phrases when we compare them. Batch learning is the learning system that the system is incapable of learning incrementally. In this system, the system trained using all the available data. At the first time, the system must consider all the data. Okay, then it takes a lot of time, and it is time consuming. We cannot ignore it. But in contrast, this learning system, we have online learning. In online learning, we feed the data step by step to the system. We have mini batches of data. Okay, and then the system, it is fast compared with batch learning, because in each step the amount of data is is too lower than batch learning. Okay. Then another thing is instance-based versus model-based learning. Model, again, if we want to understand these things, these two phrases, I think it is better we compare them. In the model-based learning, for example, consider this diagram. When we have data, the system want to generalize these features to all data. Maybe we extract the generalization rules for study new data. Okay, then for this purpose, to achieve this generalization or generalizing data, the system makes model. Okay, for example, if we have data like this, for example, okay, the system fit a line. The system fit a linear line to this data. The system models this data by a linear line. Then this pink linear line is the model of this data. Again, in contrast to this model-based learning system, we have instance-based learning. Instance-based, the system learns the example by itself. Okay, I mean the system, for example, have this triangle and have this square. Step by step, see the different data, all the data, and then consider, for example, okay, triangle has 3 angles, and squares have 3 has 4 angles. Then if we have new data in the instance space, by using similarity measures, by using a similarity measure, I can understand that it is related, this new data related to triangle or a square class. And now we want to study the main challenges of machine learning system. According to these systems, as you understand by yourself, when machine learning system need to learn, to train from the data, it needs many data, big data. And if we have insufficient quantity of training data, we had a problem in this system. Sometimes our data are not representative, or not have clear features for generalization. Sometimes our data doesn't have good quality. Okay, because of different noises, because of the method of measurement, because of the method of data acquisitions. Okay, because of many things, because of the inherent the main characteristic of data, or data doesn't have good quality. Then this poor quality affects on the machine learning system. And sometimes when we have many features, for example, we have 1 million features, but among of these features, only from these 1 million features, for example, only 100 of features is very principal, is very they have many effects for classification. Then we have to extract the main features. We have to reduce the features. And in the future sessions, step by step, we will familiar with this field. For example, feature engineering, feature selection, feature extraction, dimensional reduction, and like this. Another phrases that you may face in this field is overfitting the training data and underfitting the training data. Please consider this diagram. Our data is this square objects, this yellow square objects. In the middle diagram here, the system feed this blue diagram to the data. Then if we have new data, the system can decide the new data related to this place, where, okay? But if we have overfitting, please consider overfitting here. You know, it is the blue line, it is too accurate according only for this data. Okay, if we have data, for example, here, the system confused related to here, related to here, related to where. Okay, then in the overfitting the training data, it means that the model performs when on the training data, but it doesn't generalize well. We have low and good error in training data, but if we have test data, if we want to evaluate the new data, the error is not low. And another thing is underfitting. It is in contrast with overfitting. It is in the opposite of overfitting. It means that when it occurs when your model is too simple to learn the underlying data. Again, consider the yellow square objects. The system only fit a linear line. It is so simple. It means and it seems that the system doesn't consider and doesn't see these features. But in the balance learning and training, the system consider the data here, the data here, the data in this region, all the data. Okay. And as I said in my tagging, we have testing and validating. If we have data, okay, we cut the data to different parts, classify the data to different parts. Usually the most of data used for training. As I said before, I'm writing with mouse. Then if my handwriting is not good, because I'm writing with mouse. For example, and we consider 18% or 17% for training. And then again classify the remaining data for testing, for test, and for validation. Okay, validation. After training, it is better we evaluate our system with validation data, with cross validation data. In this way, the system updated itself by new data, and then after that we use testing the data. Then by using this system, we have better result. We have better outcomes from the machine learning system. Okay, these phrases, these words, these topics are important in this for this machine learning system, and I tried to know these words, these topics in this field. Thanks for your attention. Have a nice time.